Hello, 8th grade math students. Mr. Lawrence here, and here's day 2 of finding the nth term. Now, yesterday, all the patterns you did were linear. And how do we know they're linear? Because when you found the first difference, you got the same name over and over, same number over and over and over again, like plus 3, plus 3, plus 3. Today's are going to be a little different. So why don't you copy down number 1 here, okay? Pause the video. If you're still listening, I'm assuming you've got table number 1 copied down. And I'm going to go the same direction. I'm going to find the first differences. And I notice I'm going to have to add 3 there. And then I'm going to add 5. Ooh, they're not the same. This is different. Then I'm going to add 7. And then I'm going to add 9. And you're so smart, you can say, well, the next one I'll add 11 and then 13 and so on. And that's awesome. Except, like I said yesterday, I want to get a formula that will give me the nth term without having to figure out all the terms before it. Okay, so the first difference, it didn't match. So I'm going to go down to the second differences. And look at this. That would be plus 2, and plus 2. Since the second differences are the same, I know my pattern is going to be quadratic. Yeah, quadratic. Pretty advanced word for a kid not even in algebra yet, but I know you can handle it. Quadratic. And what that means, it's going to be n to the second power. So my nth term is going to look something like n to the second power. Now there's a little subtle point here. What number is in front of n? And hopefully you know that there's a 1 there. Okay? 1n squared, we don't need to write it, but I'm going to for this purpose. If you look, 1 is half of the second difference. Okay? This number is 1/2 of the second differences. Okay, so since it was all plus 2, plus 2, plus 2, I went ahead and wrote down 1n squared. Now I'm going to do my comparison line just like I did with the linear patterns. 1, 2, 3, 4, and 5. And I'll tell you what, just for purposes of teaching, I'm going to erase this work. I don't want you to erase your work. But just for the purposes of teaching, so it's nice and clear, and you can see what's going on, I will erase it. Okay, so now I'm going to take these numbers and substitute them in for n. So 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, and 5 squared is 25. I'm going to ask myself, how do I turn the green ones into the black ones? Well, I think I take away 4. Let's see, 4 into 0, I'd have to take away 4. 9 to 5, I'm going to take away 4. So my pattern is going to be n squared minus 4. To figure out the 11th term, I will do 11, I guess I should put the 1 out front, 1 times 11 squared minus 4. And that's going to equal 1 times 121, right? 11 times 11, which is 121, minus 4 is 117. And so my 11th term of this pattern is 117. That's pretty easy. It's very similar to what we did yesterday. You just have to notice that the second differences are the same, and therefore the exponent on the variable is going to be the second power. Okay? So here's number 2. Go ahead and copy down the solutions. We'll do this one together, or copy down the table. So let's see, my first differences look like they're going to be, let's see, we got plus 6, plus 10, plus 14, I believe, and plus 18. They don't match, I'll go to the second differences. Oh, look at that, plus 4, and plus 4. So I know this is quadratic because my second differences are the same, and it's going to be an n squared, but the number in front of n squared is going to be 2, right? I take half of that number. All right, get ready to do my comparison line so I can adjust my 2n squared formula. And let's see, I've got to be careful now. I've got to follow the order of operations. So I've got to square the number and then double it. Square the number and multiply by 2. So if I put a 1 in here, it's going to be what? 2 times 1 squared. So it's 1 squared is 1 times 2 is 2. This one here is going to be, 2 squared is 4 times 2 is 8. Then I'll have 2 times 3 squared. 18 times 2, 9 times 2 is 18. And then for this one, I have to square 4 to get 16, double that to get 32. And then I have to do the same for 5. 5 squared is 25, times 2 is 50. And if you look, to turn the green ones into the black ones, it looks like I have to add 1 each time. Every single time I'm adding 1. So my nth term will be 2n squared plus 1. All right, to do the 11th one, 11th term, I'm going to do this. Square it, I'm going to add 1. Order of operations, so important. 2 times 121 plus 1. So that's going to be 242 plus 1 is going to be 243. 243 is the 11th term in the sequence, and I didn't have to go and figure out the first 10 terms. All right, here's one for you to try. Go ahead and pause the video. If you're still watching, I'm assuming you're ready to see my solution. So again, I'm going to go first differences, plus 8, plus 14, plus 20, and plus 26. So the second differences are plus 6 every single time. Okay, so I know it's going to be n squared, but it'll be half of 6, so it'll be 3n squared, right? 1, 2, 3, 4, 5. 1 squared is 1 times 3 is 3. 2 squared is 4 times 3 is 12. 3 squared is 9 times 3 is 27. 16 times 3 is 48. And 25 times 3 is 75. Uh-oh, this is weird. I kind of looked ahead and peeked. Let me erase this work here. Again, not because you should, but because I want to make it crystal clear what's going on. So, I'm going to go do my comparison line. And when I do my comparison line, how do I turn the green ones into the black ones? Well, I subtract 1. But look here, I don't subtract 1, do I? I subtract 2. And then I subtract 3. And then I subtract 4. And then I subtract 5. Huh. I'm subtracting a different amount in each one. But did you notice on the first one I subtracted 1. The second one I subtract 2. Third one I subtract 3. What do you think I'm going to subtract on the nth one? I'm going to subtract n. This pattern is going to be 3n squared minus n. Now, to do the 11th term, I'm going to go 3 times the quantity of 11 squared. And then I'm going to subtract 11. So that's going to be 3 times 121 minus 11. I believe that's going to be 363. Take away 11. And that should equal 352. And that will be the 11th term. 352. And there you go. All right. Number 4. Again, why don't you pause the video and see if you can do this one on your own. Here comes my solution. If you're watching, I'm assuming you have already attempted on your own. Looks like this is going to be minus 6. This is minus 10. This is minus 14. And then minus 18. The second difference is, looks like I'm going to subtract 4, and subtract 4. So again, I have a quadratic pattern. So it's going to be n squared. But then It's going to be minus 2n. Where's the minus 2 coming from? Half of negative 4. So I do my comparison line. 1 squared is 1 times negative 2 is negative 2. 2 squared is 4 times negative 2 is negative 8. 3 squared is 9, negative 18. She gets negative 32, I believe. And then negative 50. And it looks like each time turning green to black, I'm going to get plus 5. Plus 5. And sure enough, negative 18 plus 5 is negative 13. There it is. So I'm going to have negative 2n squared plus 5. So there's my nth term. To do 11, I'll do negative 2 times 11 squared plus 5. Negative 2 times 121 plus 5. That's going to equal negative 242 plus 5, which should equal negative 237. And there it is, negative 237. Oh, nope, that's incorrect. No, that's right. It's not plus, yeah, it is plus 5, silly me. Negative 237. Sorry, for a minute I thought I had a silly mistake, but that should be right. Okay? All right, Mr. Lawrence signing off. Have a good day, everybody.